Thank you. Thank you for the folks that are attending live here. Huge thank you to the folks over at Pax8 and SentinelOne. And I'll let the folks from Pax8 and SentinelOne introduce themselves.
Yeah, I guess I'll go first unless you want to, William. So my name's Steve Overko. I'm a solutions engineer at SentinelOne, and I actually primarily focus on our MSP partners and our distribution partners. So,
my name's Alex Korn. I'm the account manager over here for corporate data and voice. I work closely with Will Lester, who I'll let introduce himself. Yeah, go ahead, Will.
Hey everybody, my name is Will. I'm one of the security consultants here at Pax8. So work really closely with corporate data and voice here, as well as some other MSP partners on the East Coast to kind of help get everything secure, get everyone taken care of.
Excellent. Appreciate it, guys. So today's agenda, I have a couple of things to say here. I'll wrap that up and turn it over to the folks over at SentinelOne and Pax8. And from there, we'll do a wrap up at the end. We have a couple of raffle prizes that we'll talk about, and then we'll let you get on your way with the rest of your day. So in attendance, some of us are in attendance, so sorry about that. Kelly, why don't you start us off? Just say hello.
Well, good morning, everybody. Thank you for joining. I'm Kelly with Corporate Data and Voice. I think a lot of you know me, or I look familiar to many of you, and very excited to have you here today and to learn more about SentinelOne. Thank you.
Excellent. Christy? Say hello.
Good morning, everybody. I am Christy Sturgeon. I'm with Corporate Data. Thank you for joining us today, and excited to see who is ready to work with SentinelOne.
Excellent. Rachel, you want to say hello?
Good morning, everyone. Rachel Neary with Corporate Data. It's nice to see everyone.
Awesome. Pete?
Good morning, guys. Pete Lankarge here with CDVS. I'm down in Rhode Island, focused on Southern New England, and thank you, everybody, for joining this morning.
All right. And Bill is here. He's not on our slide, but Bill, you want to say good morning?
Good morning, all. Bill Lavoie from Corporate Data and Voice. Just excited to work with partners on this new products.
Excellent. And I'm Joe Spampanato from Corporate Data as well. All right. So a couple of housekeeping items. During the presentation, if you wouldn't mind muting your microphone and your video so we can focus on what is being, the information that is being presented. We are, as I already mentioned, we are recording this session. So for the folks that weren't able to join, or if you want people in your organization to see this information that we're presenting today, we will be forwarding the link, correct, Christy? We'll be forwarding the link to everyone after the session?
Yep. Yes.
Okay. Takes us about a day or two to get it all wrapped up, and we post it on, are we still posting it on our YouTube channel?
Yep.
So with our other sessions that we've been doing, names will be drawn at the end for the 2 e-gift cards, $50 e-gift cards. So for you will be entered to win one of the two by attending and still being in attendance at the end. For every question that is asked, we will put an additional name in the hat for you, so more chances to win. So we do encourage great questions during the presentation. Just chat those questions in, and we'll get those questions answered. For the folks that don't know who Corporate Data is, we founded in 2003 with a focus of the converged network. We take a consultative approach of helping our customers improve communications, improve security, and the like. It's not about us, it's about you. So listening is one of our biggest jobs, listening to what you need, listening to your challenges, and understanding those and bringing the right solution to you to help solve those challenges that you have. We act as an extension of your team with a high touch. With COVID, no actual touching, right? With a high touch approach, without actually touching, right? So project planning, implementation, ongoing support, that's our forte. We have a high, extremely high customer retention rate, and we are definitely passionate about what we do and how we execute our jobs. Our pillars are honesty, integrity, and accountability. Pretty straightforward how we do business. Why we host our Tech Talks live series, we have had a long tradition of doing or hosting lunch and learns. Unfortunately, with the pandemic, we had to turn to virtual sessions like this. We've had some great sessions, a lot of content. Again, you will be receiving the link to this recording, but you'll see some other pre-recorded sessions out there on our YouTube channel. Definitely a strong reputation around educating our clients, continuing to educate our clients around the solutions that we provide. As I said, the pandemic definitely forced us to change the format to virtual, but we are definitely looking forward to resuming our in-person events when appropriate. And I think that, that was supposed to be the last slide. For some reason, that was hidden. And now for our feature presentation, I'm going to turn it over to folks over at SentinelOne and PAX8.
Cool. Awesome.
Great.
Let me go ahead and share my screen. Make sure that's the right one. And hopefully everybody can see that, right? All right. Awesome.
Yes.
So yeah, for those just jumping in, again, my name's Steve Overko. If you ever run into me, just call me Steve-O. That's what everybody does. But today we're going to talk about the platform that's being used for endpoint security. And really, it's for those not familiar, it's really a combination of two different solutions. The first is, of course, it's an endpoint protection solution. And second, it's an endpoint detection and response solution. Now, for a lot of other products out there, you might need two different products to do the same thing. But for us, we do both all with a single agent that sits on an endpoint. So first and foremost, let's talk about protection. So right away, the way that we approach protection is it's very different than what you may be used to, especially if maybe you're used to more of a traditional approach to endpoint security, like with an antivirus or a solution like that. So instead of using traditional, what you would call signatures or traditional, I guess, older forms of AI, like old heuristics engines, things like that, we approach this a little bit differently. So the whole solution is powered by artificial intelligence. And one of the key differences with how we use that is we actually put all the logic local to the endpoint. So what that means is the agents actually don't need to stream all the information about everything that's happening on an endpoint up to the cloud to get it crunched up there and then have a response sent back down to the agent. A lot of the EDRs out there, they do it that way. And one of the biggest Achilles heels for them, I'm getting a little bit of feedback from someone's mic. And one of the biggest Achilles heels for them is the network connection. What if you're, at a Starbucks, or what if you're about to jump on a plane and you don't have a connection to the internet? And you plug in that thumb drive, and sure enough, there's an attack sitting on it. Well, you want your endpoint security solution to be able to protect you, no matter where your endpoint is, no matter what type of connection it has. So that's one of the big differentiators for us. We bake all of our logic, all of our AI right into the agent that sits on the endpoint. There's another reason why that helps a lot too, and it helps deal with what we like to call high velocity attacks. So for example, a lot of the ransomware that's out there today, it can rifle through a system in seconds, right? A lot of products out there, again, if they only have a certain amount of logic local and they have to process a lot of it up in the cloud, there's a lag time that the agent would have to deal with in order to respond to it and prevent it from getting further. With our agent, because it processes it all at what we like to call machine speed, we can respond literally in milliseconds to whatever we're seeing on the endpoint. So we'll talk a little bit more about these. I have a cool little detection flow that we'll go through, and then I'll actually demonstrate live an attack on an endpoint and go through what that looks like. Oh, yes, go ahead.
Steve, yeah, I got a private message here from somebody. Question is, since it's running locally, hate to put words in your mouth, but it sounds like the application is running locally, does it impact processing power or processing speed?
So as far as they're basically just asking about resource consumption and performance, it sounds like. So as far as performance goes, typically, let's say on a average Windows system with a typical workload, in our PC mark testing and our benchmarking, the agents typically use right around 1% to 2% CPU. And I'll pivot into an endpoint and we can look at that too in a sec. The latest agent, which we're about to release, actually dipped underneath that average. So we were averaging like 0.8% CPU with that one. So it's actually the way that we do the analysis in parallel with what's going on is a lot more streamlined. And it's a lot more lightweight than, like, for instance, I used to work for a traditional AV, and when they would do behavioral analysis, they would actually just try to sandbox the application or the process, and that was very, very heavy the way they did it. So we do it a little bit differently. We monitor things in parallel with them happening, and if at any point in time we don't like what we see, we can kill it right there and it doesn't progress further. But I'll talk a little bit more about that in a minute. From a memory perspective, typically, again, average Windows workstation, we usually see between 130 megs to 250 megs of memory being used. That's relative to what's going on an endpoint. So whenever someone gives you any type of average performance or resource numbers, try it out in your environment. Every environment's different. You're running different software, different hardware, you name it. So I always recommend just giving it a roll. But that's typically what we see is in that range. So still a lot more lightweight than, again, another traditional solution. And it still gives us more than enough power to respond to things, process it, and deal with it in real time. So hopefully that helps. On Mac and Linux, it's even more lightweight than that. So if you've got a mixed environment, it only gets better from a resource usage perspective. Cool. So I'll keep trucking along. If there are any other questions, though, feel free to throw them in the chat, and we will get to them. For some reason, my chat's not working, by the way. So if you want to just shout them out when they pop in, I can deal with them then.
Yep.
So as far as the other part to it, so once we do detect something, responding to it is equal as important. So for instance, with most of the products out there today, you can kill the processes involved in an attack. You can quarantine the files that those attacks either drop or, the file that started the attack. Those are what I like to call the table stakes responses. Everybody on the market should be able to do that. When you start getting into some of the EDR solutions, a lot of them can also do what we like to call device isolation. So essentially, that host gets isolated on the network and it cannot talk to anything else, and no one else can talk to it. So we do have that capability as well. All of these responses can be automated or manually performed. Where we step ahead a little bit, though, is in our remediation and rollback capabilities. So for instance, if let's say by the time we alert on something, maybe everything it did up to a certain point normally looks completely benign, but once they tack on another activity that it performs on the endpoint, maybe at that point we say, okay, yeah, this combined with everything else does not look good. We can kill the process tree, so the attack stops right there. Again, we can quarantine any files, but what if the attack actually did make a change to the endpoint? So what if it added a registry key? Or what if it added a scheduled task for something like persistence? We see this a lot, again, with ransomware and other attacks. They want to make sure that if you try to reboot the machine thinking it'll clear everything up, they have a task that's set to restart the ransomware when you log back in. So stuff like that, what we can do is we can completely remove any of those changes made to the endpoint, and heaven forbid, if that storyline is what we like to call it, was able to delete anything on the endpoint. So let's say maybe you had some sensitive documents, and they were able to delete it or alter it or heaven forbid encrypt it before we alerted on it, which is extremely rare. What we can actually do is we can revert those files back to a previous state using something known as volume shadow copy on Windows. Now on Mac and Linux, we can do all of these capabilities minus the rollback, because there's just no, they don't have something like volume shadow copies that we can tap into. Yeah, again, I'll show it live in a minute here once we get to the demo portion. And I did see that question float in, Joe. I'm going to wait till the demo because I'll actually show it. So.
Okay, great, thank you.
Cool. So, other than detecting threats and responding to them, there is another aspect to the endpoint that the team here is using, and that is what we like to call our control capabilities. So what this adds into the solution is I like to call them kind of like your AV suite features. So for instance, the ability to centrally orchestrate and control the local host firewalls on all the endpoints. That is a capability of the platform. So it's one less thing to go into and have to manage in a separate tool. Like maybe you're trying to do all your firewall rules through GPOs. Well, GPOs are not fun to deal with usually. So being able to do it centrally right in the platform is pretty sleek. Again, we can do that for Mac and Linux as well. In addition to that, we also have peripheral device controls. So if any of you, maybe you have, retail chains, or maybe you have kiosk computers or something like that in a lobby, or maybe you have loaners that you give out, things like that, and you want to keep those devices locked down as much as possible, we can actually control any devices plugged in via USB or even connected via Bluetooth on those endpoints. The third big piece that we do is we can inventory all the applications on an endpoint, and part of that inventorying process is actually mapping those applications to known exploits and CVEs. So for instance, if I'm using maybe it's a really old version of Adobe Reader or something like that, and there's an exploit for that, that's something that we can actually report on and say, hey, you need to patch this application because you have X, Y, and Z CVEs for it on that endpoint based on the version that we're seeing on the endpoint. And then last but not least, the team has the ability to remote shell into endpoints to provide additional assistance. So if they need to run any additional commands or things like that, they have that capability at their disposal. So those are some of the suite features. Again, it's really there to provide some additional lockdown capabilities and management capabilities without needing to deploy another agent or go through another solution. So how does all this flow together? So I'm going to kind of bring it back to that second slide where I showed or talked about some of the detection and defensive capabilities of the agent. I'm going to show that in a little bit different way, just because this is the way that I think clicks better with most people. So I'm going to go through a scenario. So let's say I've got a scenario where an end user, maybe they cracked open their email. So they've cracked open Outlook and they've opened an email attachment. So they've downloaded that attachment and it hits the computer. How does our system help cope with that? How does it see what's going on? How does it deal with it? So the first thing that we do, and I don't bother putting this on the slide because again, I'll use the word table stakes. I like using that word a lot, but it's something rather basic that a lot of solutions use in the market. And that is, even though we're not processing the files up in the cloud, there is one check that we do, and that is a reputation or intelligence check on specifically just files. So if a file hits the endpoint, we calculate the hash for it, and we do check that against a cloud intelligence feed. So we, of course, have our own threat research team. We also partner with other organizations like Recorded Future. They're probably the biggest threat intel solution in the market. We also partner with Reversing Labs and a bunch of others. And all that intelligence allows us to check certain files and things against it. So rather than having signature databases that download to an endpoint that you have to deal with every hour like you would with a traditional product, instead we can quickly calculate a hash, check it against the feed, and if we have a hit, it's computationally cheap to just tell the agent, hey, quarantine it. So that's a really quick check. Happens incredibly fast. That's the only part that does depend on a network connection, though. Having said that, from that point forward, it's all advanced modern engines from there. So for instance, the first thing that we would do, let's just say there's no reputation on that file that got pulled down. Well, the first thing we're going to do is we're actually going to take a look at it with what we call our static file AI. And this approaches it a little bit differently, again, than some of your traditional solutions. So rather than having to go line by line, looking through patterns in code, rather than needing to grab the file and sandbox it or lock the file while it's analyzed, that's usually the big, when you hear people complaining about how antivirus is slowing down their computer, or it's taking forever for a file to open, it's usually because that solution probably locks the file down while it's trying to see what it actually is or what it might be doing, etc. We don't have to do any of that. So instead, what we do is we take a different approach. We take a look at the file and we extract what are known as features. Another word for features would be characteristics. So for instance, we'll take a look at the header of the file. So we might say, is this document actually a document, or is it really an executable that looks like a document? We might take a look at the chemical makeup of the file, let's say. So is there a lot of obfuscation in the code, meaning they could be trying to hide what the file is going to do if it gets opened. There's tens of thousands of these that we extrapolate when we look at a file. And based on the combination of those features, the algorithm will rate the file. So it'll either say, hey, it's a high confidence malicious file, it's a lower confidence suspicious file, or it's completely benign. If at any point in time we see it as malicious or suspicious based on how the solution is set up, we can kill and quarantine that file immediately. And then it doesn't go on from there. Now, the next part is my favorite part, and that's the behavioral model. This part is extremely important because it'll help protect you against attacks that don't even use files. So for instance, you might navigate to a website one day, and who knows, maybe that website got hacked. You hear about WordPress sites getting hacked all the time. Oftentimes what attackers can do is they can use legitimate websites if they kind of take them over, and they can use that to kind of profile the computers that are visiting that website. So they might be able to say, oh, this person's using this version of Google Chrome or this web browser. There are exploits for that. Okay, let's pivot from the site, load some code into memory, and then from there get a connection to the endpoint. You might be dealing with other attacks like living off the land techniques, where the attacker simply just uses trusted tools, which are built right into the endpoint. I'll provide a funny story about that later. And then from there, we can deal with maybe a computer joins the network and tries to laterally attack another computer. That's all getting crunched by our behavioral AI. So the way that this works a little bit differently is we do something unique that we call storylining with our platform. So let's pretend that this white dot on my little graph here, let's say that that's Microsoft Outlook. The moment that the user clicks on the Word document, it spawns Microsoft Word to open the document. Right then and there, we tag Microsoft Word opening the document with what we like to call a storyline ID in our platform. From there, any new activity produced by that process, so if it writes a file to disk, if it opens, starts another process, talks over the network, the agent immediately can tag those additional events with that same ID, and the data is already correlated. So every time there's a new activity, the agent reassesses the storyline, says, hey, this behavior combined with this behavior, good or bad, and based on its verdict, it can issue any number of responses. What this also means is for the security team that's managing the solution for you, they can review these alerts and they have all the data already correlated. They don't have to waste any time trying to fetch logs, line things up, which used to take hours. Now it's already provided, and it just takes a couple seconds, maybe a minute for them to understand what's going on in the endpoint. So I'll show this a little bit more in depth. This will be the last slide, and then we'll hop right into a demonstration. But to follow it up, I mentioned some responses on the third slide that we covered. This is kind of just rehashing some of those. So at any point in time, if we see any malicious activity, bad files, etc., we do have a number of responses that we can provide to either prevent that from getting further, to clean up if it was able to make changes, or to further lock down the endpoint. So I'd rather actually just show some of these in the demo. So we're going to go ahead and pivot in and get a live look at the platform. I guess before I do that, Joe, were there any other questions that came in other than does the product use restore points?
I have not seen any, so that's the one that I still need to cover.
Cool. So I will cover that in a sec because we're actually going to use those in a minute. So everyone at this point should see the SentinelOne management console. So traditionally, how you're built out when you're being managed is you'll have a site created for you. And this will kind of be like your own little private silo, your own tenant, so to speak. This is where all your systems are going to live. Now I've broken mine down into further groups. So I have a workstations group here, and this is actually where my my victim computer for the day is going to live. So it's this guy right here. Now, for the sake of demonstration, the way that I'm going to do this is I'm actually going to let the attack I'm about to do get all the way through. And the reason why I'm going to do it that way is because I can't show you response capabilities if nothing happens. So normally, just note your product in production will be running in protect mode, where the agent, as you can see here, these protect levels come up. It'll automatically be configured to respond to malicious activity. So it's not going to wait for a human to push a button like I'm about to do. The agent will immediately respond and take care of it. But in my case, I'm running it in this detect mode. Typically, it's only used in an initial deployment, but this is going to let it through. I'll still get alerts. I'll still be able to respond to it manually. But again, it's not a sexy demo if I execute something and it gets killed in 1 millisecond. So, so the way that I have my attack set up is on the left-hand side. This is just a simple Kali Linux server that I have set up. And this is going to act as my command and control server. So this is the attacking computer, for those that don't know what that means. On the right-hand side, this will be my victim. So this is a Windows 10 machine, and I'm logged in as a local administrative user. So the first thing I'm going to do is I'm going to go ahead and crack open a document that I have here on my desktop. Typically, I like to launch this from an email client or somewhere else, but I was having some issues with my Outlook on this box this morning. So we're going to do it the old-fashioned way, and I'll let you guys use your imagination as to how the file got there. Maybe it came from a USB drive, what have you. There could be a lot of different ways it got there. So we'll ignore me having to accept my EULA and licensing agreements with Microsoft. But right away, the moment that I opened the document, you could see that the agent was actually generating an alert on it. And on the left-hand side, we can actually see that we have a connection to the command and control server. just from opening the document. Didn't have to have the user do anything else. They just had to crack it open. So what this is doing is the agent actually didn't statically alert on the file, meaning there was no signature for the file. This is not a known file. There's no reputation for it. And statically, the file actually looks fine. It's just a Word document with a macro payload. So we're not going to alert just for that reason, because there are plenty of legitimate documents that, of course, have macros in them. Having said that, if we dig into the alert here, we can actually see some pretty useful information. Now, when I first started in the industry, I worked for a traditional AV company. I had none of this visibility. The only thing that I saw was, hey, we detected a file, and I just kind of had to trust the black box that it took care of everything, and depend on end users reporting anything else to me. Or I'd have to follow up by fetching a log, spending the next few hours figuring out, okay, does everything look good on the endpoint? Don't have to do that with our platform. So right away here, I can see the document that got cracked open. I can see where it was located. I can see the user that opened it. And I can tell that they likely just double clicked it simply because the originating process here is Windows File Explorer. If this came from an email, or if it came from maybe a website or something like that, I would actually see something like Outlook.exe here, or I'd see the web browser here. So I'd have some information as to where it came from. From the right-hand side, I can also see, this is kind of like us showing our homework. So we can see actually why we're alerted on it. So number one, we can see our behavioral indicators. So the document's acting abnormally. We can actually tell based on the macro payload and the code that was run that it's actually a pen testing framework that I'm using. And yes, I'm using Metasploit. Now, if I wanted to drill into these, one of the cool things that we do is we link everything to the MITRE ATT&CK framework. If you're not familiar with the framework, I highly recommend looking into it. It provides a lot of useful insight into the tactics and techniques that the attacker, in this case, is using to target my specific environment. Now, since this one was behaviorally detected, we actually have some additional information that we can show in the form of a visual storyline. So this is actually my favorite part of the whole solution, because it makes life a million times easier for an analyst to see what's happening rather than digging through raw logs. So right here, again, we can see that the detection really started when I opened the Word document. And I can see exactly how it gets executed here. So what commands does it run with? Does the process have root on the system, so on and so forth. But if I scroll down, I can actually see everything the document did. So I can see every file it wrote, every file it edited, deleted, you name it. I can see all the network connections. These are actually completely trusted. I've checked all the IPs before, so these are all Microsoft servers. When I open Word, they want to know everything about me, right? So what'd you have for lunch today? Is the product license, all that fun stuff. But what does look a little weird in this case is the Word document had a macro payload in it, which spawned another process. And that process, if I take a closer look, allocated memory, and it actually communicated to another IP out on the network. So this is my command and control server, and this is the default ports that it's talking over. So right away, we can see how this all started. Now, I'm going to go through a few extra steps in the attack because I'm not doing a normal ransomware attack. I'm doing a few other things. Before I progress, though, we'll take a look so you can see the agent performance. So it's really not using that much CPU, definitely less than 1% on average, and it's really not using that much memory, so sub 250 megs. Now, in this case, what I'm going to do is my next step, I don't want anyone seeing what's actually, what I'm doing on the endpoint as the attacker. So I'm actually going to migrate my attack to hide, and it's going to look like Microsoft OneDrive is doing everything. So hopefully no one should be able to see it up front what's going on unless they had a tool like ours. The next step that I'm going to do is I'm going to use a bypass So that way I can elevate privileges without prompting the user with user access control. On Windows, specifically, with Windows 10, there's a popular bypass. It still works on fully patched Windows 10 boxes, and it's called the FOD helper bypass. And what this will let me do is it'll let me use FOD helper, which is a process built into Windows. It'll let me use that to spawn system level processes without prompting the user for anything. So that'll be my next step here in my script. I'm going to have it spawn 2 system level processes, and that'll give me all the permissions I need to do anything I want on the endpoint. Now, again, for those that are maybe joining a little later, or maybe you're skipping around the recording, I would have not gotten this far if the product was in protect mode. So again, the moment I cracked open the Word doc, this would have actually been behaviorally detected, and I wouldn't be getting this far. So in this case, I've got my 2 processes here. So I just have a randomly generated name that I do for them. But these give me all the permissions I need to do what I need to do on the endpoint. If I go back to our alert here, we'll take another look. You can see my threat indicators grew. So one of the neat things that we do, because we correlate everything on a storyline, we don't have to generate like a million alerts for what's going on here. We know it's all related. So we correlate that for the security analyst. So that way, again, they don't have to look through like 50 alerts and see which ones are related and what order they happened in. They don't have to do any of that. The agent does that for them. So here on the right, we can see my additional indicators. So my UAC bypass attempts, I can see privilege escalation going on. So when I spawned my system level processes, that's all reported in, easy to digest. If I take a look and refresh my Explore tab here, I can actually see, again, FOD helper being used for the bypass. So I can see the command line prompt, the commands that are being run. I have full visibility into what's going on in this endpoint. So what I'm going to do is, for sake of time, because I know I'm chewing up a lot, let's get to the fun part and let's start actually doing some damage. So the first thing that I'm going to do is, rather than just straight up encrypt the data, some ransomware actors do a few other things. A lot of them like to do extortion now. So what they'll do is they'll zip up data that they think is valuable, or you might call it staging. That's what we call it. So in this case, you can see I made a little zip file in my sensitive data folder, and I'm actually uploading it to the command and control server. If I was a little less lazy with my script, I'd do something cool like dump the data in little tidbits to like Twitter messages and stuff like that. But yeah, I kept it kind of simple. The next
Steve.
step. Yeah, go ahead.
Steve, I have a question.
Yeah.
Just mentioned zip. So is there any protection, or can you lock down zip folders, zip files?
I mean, this is completely benign. Zipping up data on an endpoint is completely benign. So I would hope that your endpoint security wouldn't alert on this, because you'll be getting a lot of false positives if that's the case. In this case, though, I'll show you how we can actually see what's going on and how that helps us understand what's actually happening on the endpoint. So for instance, in this case, the data is zipped up. Again, zipping data in and of itself isn't malicious, but even copying data from one point to another, technically no product's usually going to alert on that either. So copying data into Dropbox, for instance, that's not necessarily malicious. But what I'm going to do to follow this up is I'm going to go ahead and delete the data. Again, this is technically a benign command, simply just deleting data on a hard drive. And then from there, I'll actually drop the ransomware payload and we'll encrypt the rest of the endpoint. Now, this is why having an EDR is important. So Joe, to your point, you're probably thinking, okay, how can I detect people using zip maliciously? Now, just zipping a document is not a bad thing. But the benefit to having an EDR platform is the fact that we can actually see this behavior. We can show it to you on a storyline, and that allows the analyst to see, okay, the attacker didn't simply just get a connection to the endpoint. We'll be able to see where the attacker zipped up data, where they communicated that to, so we can see data exfiltration occurring. And once the ransomware here is done, I'll pop open my documents folder here, so that way we can see it start encrypting everything. We can also see everything that was doing. So I'll give it a second. It typically takes like 30 seconds to a minute for this ransomware to go through. For this one, I'm using GanCrab. Usually I'll switch it up and use different strands. I like to use GanCrab though, because it doesn't need to talk to a command and control server. So it can actually, you could be literally sitting on an airplane. This could be laced into something that you open, and it'll do the entire encryption process locally on the computer. So here, I can see all my data is encrypted. I can see the ransomware note and all that fun stuff dropped in every directory. So at this point, hopefully, A, it doesn't get this far, but B, the end user would be calling you up saying, hey, what's going on? So if I go back to my alert, we can see that it's continuing to get updated. So I can see, okay, whatever it is, it's definitely behaving like ransomware. We can tell based on, it rifling through files, encrypting data, so on and so forth. And if we jump into the Explore tab and refresh it, I'll give it another sec here. It's got to load a couple thousand new events. I'm going to jump to the actual ransomware process. And here we can see all the files that it's going through and encrypting, deleting, renaming, you name it. So here we can see it renaming all my documents to have the fun little crab extension at the end, which tells me that the data is encrypted. Now to the earlier comment, we can also see a few other things if we look at this storyline. So we can see in order to zip up the data earlier, Joe, I actually didn't use something built into Windows. I dropped a popular program called 7-Zip, executed that on the computer, and you can see based on the command here, the folder I was targeting was that user's sensitive documents folder. Now, if I take a look at the shell session, the PowerShell session that spawned that, I can actually see a network connection back to the command and control server. So I can assume that whoever just did this, they have access to the data and we're able to copy it. It looks like I have even more data. Now, one of the things that the ransomware will do is it will do a shadow copy delete. I'll go back to a question that was asked earlier about, do you use restore points? How do you roll back data? So when SentinelOne installs on a Windows endpoint, we actually have our own VSS writer that gets put in place, and we use volume shadow copies on the endpoint. Now, typically, what'll happen, and I'll just wait for the final bit of data to hit here. What'll happen is pretty much all ransomware. I'll refresh it one more time because it looks like the story is still unfolding. Most ransomware will try to delete shadow copies. So I'm just waiting for that bit of data to come up. That's pretty much par for the course. Now, one thing that we can do is I'm going to go ahead and mitigate this. We're going to revert back everything that happened using those shadow copies. Now, what it's going to do is it's going to kill all the processes in the attack, which will cut off the connection here on the left. So we'll see it drop the connection. It's going to clean up. So any documents that were dropped by the attack, any reg edits that were made, etc., those all get removed from the system. So we'll see these little text files disappear once it starts remediating them. And then we'll actually see it starting to revert the files back to their previous snapshot state. Now, one of the things that we do for those volume shadow copies is we actually apply our own anti-tampering technology that protects our own software on an endpoint. We apply that to the snapshots. So for instance, I'm a full administrator on this box. If I go to run command line as an admin, and I try to do typically what most ransomware does, and that's sysadmin, delete shadows all. If I try to delete all the shadow copies, looks like it went through. Now, if I go to list the shadows that are still there, they're actually all still there. So that's all part of our anti-tampering. We'll intercept the command. We'll make sure that no one can tamper with the snapshots. so that way we can always use them to help recover the system. Now in a sec here, it's still rifling through a couple thousand files. We should also see it actually recover the data in this sensitive folder as well. So it'll do that in a couple seconds. So even the data that I deleted will actually eventually get recovered. So, but yeah. So,
Question.
oh yeah, go ahead.
I know, you know, the product will protect Macs, right? So
Yep.
does it matter if it's an Intel based Mac versus the M1 chip version? And B, does it create these shadow copies? If you can talk about Macs.
So, so for Macs, we support both the Intel chips and the M1 chips. I actually have a lot of M1 chip devices in my house, and as you can tell, I'm actually running on a Mac right now. This one's an Intel-based one. So we do have agents, which will cover both. So we'll support anything. I believe it's still Mojave all the way up through the latest Big Sur release, and I always forget the name of the new one that's coming out. Is it Monterey or something like that? I'll have to double check. I'm spacing on it. But we will, of course, support the newest Mac OS version, which is impending release pretty soon. From a feature perspective, Mac and Linux devices get pretty much, well, they get all the same features as the Windows agent. The only difference is on Mac and Linux, we do not have a rollback function. This is because a facility like volume shadow copies doesn't exist on those platforms. Volume shadow copies are a technology built into Windows. It's a Microsoft technology. On Mac, technically you have Time Machine, but they haven't opened that up for us to use, for third-party vendors to use, the same way that we do volume shadow copies. When you're on a Mac system, you have to play by Apple's rules. So, but other than that, you'll get the same level of visibility. So for instance, here, for behavioral detections, you'll still get a full storyline as to everything that happened. And the agent will be able to use that storyline data to still remediate things on those devices. So for instance, if someone was able to drop another file on a Mac system, or they were able to modify a file or something like that, we can still remediate and remove that file or that change. And then I just want to show this piece because it's showing the shadow copy delete command being run. So this ransomware did do it. But yeah, so that's hopefully that helped answer that question. And I forget who asked the snapshots question. Hopefully that helped you understand what was going on behind the scenes as well. But yeah, I guess I'll pause since we have a couple minutes left. Does anyone have any questions, whether it's for me or for anyone else on the webinar?
Doesn't look it, but John Dottie, did that answer your question that you had asked earlier? Looks like Dave may have a question here. So
no. I just want to say thank you, Steve. That was great, detailed information about what goes on behind the scenes and what can happen. Jeez.
Awesome. Yeah,
Steve, can you turn on the automated process and go through the automated response, what it looks like to the client when it happens when you're in the normal mode of detect, quarantine and kill?
Yeah, it's definitely not going to be as sexy as the demo that I just did, but let me switch the endpoint into protect mode, and I have to revert back the image because I wiped all the ransomware payloads off the endpoint when I did that. So let me just restore this real quick. And we'll start with a fresh machine with a fresh batch of threats on it. Mm-hmm. And we'll go back through it. Boom. So give me 2 seconds to just get these back up. So that guy up, and I'll wait for this box to go. So yeah, as I mentioned earlier, you should technically never really be running in this detect mode that I used for the demo. This is usually only used when onboarding a new customer. So for instance, we can run side by side with the previous endpoint security product in most cases in order to do a nice smooth transition. The one thing that I hated doing the most when I worked at my last company, we had to uninstall the old AV and then you kind of like start a stopwatch because now you have a security gap until you can get that system protected with the new product. You don't have to worry about that rush with us because we can run side by side in this mode and make it a nice smooth quiet transition in. But for the sake, we'll make sure that we're running in protect mode. It's set to kill and quarantine the moment it sees any malicious activity. So we'll go ahead and do that. And just to make sure that my agent got the policy, I'm just going to send a quick command here. We'll send a message and I'll just say got it, so I know the agent synced. So let me log into my Kali box. We'll get my script up and running and we'll go through the same attack again. Start attack, boom, and that should get my server up and running. Cool. So this one should have the policy because it just synced with my command. So yeah, let's go ahead and try to open the document again. And I didn't even have time to hit accept in the document window. So we can see here that the moment the Word document spawned the other process and it made the connection here, we determined that to be malicious and we instantly killed the process, quarantined the Word document right off the endpoint, and it closed the connection, so the attacker no longer has access to the endpoint. So that's what it would have looked like, and my demo would have been a lot shorter if I had it running in that mode.
And how'd that report back on the console?
Yep, so let's pivot back over. So if we jump back into our incidents tab here, we can see that it actually knew that it was related to the attack that I ran before it, because we can actually sense similarities with the attack, whether the hash of the file was the same or things like that. So the way that this one looked in comparison to the other one was we can see the 5 threat indicators for why we initially alerted on it. And if we take a look at the storyline, it only got as far, again, as the document spawning the process and reaching out to that IP address. And that's the point where it got killed. The cool part is you can actually see the response time of the agent. So here you can see that we killed both those processes in around 100 milliseconds, so less than a second. We can see that we quarantined the 3 files. So one was, there's a Word document that I opened, right? That Word document actually writes 2 more files to the endpoint, one of them being this executable. So we can see that it actually quarantined those as well in that same 100 millisecond span. So that's why, again, having the logic local is very important. It allows us to respond that fast to what's happening. So
cool.
Okay. Awesome. Yeah, I guess we still got a minute, so I'll hang on and see if there's any other questions, or if you guys want to wrap it up with something, I'll let you guys close it out.
Yeah, I think we're good, Steve. That was as Dave already mentioned. That was great detail, overview. So thank you very much. Alex, Will, do you have anything to add before we do a quick drawing?
I think something I would kind of just add in there to just kind of keep it really high level is to keep in mind that to everything Steve showed us, right? This is a real shift from no longer write a big book of signatures. It's looking at what is something doing. And that just allows you to be so much more protected against these 0 days that are out there. I'm sure you guys have all, seen the news in the last 6 months. The threat landscape is getting scarier and scarier every day. And that's why it's really important to adjust your tools and your strategy with the way times are changing. That would be kind of the 10 cents I would add in here to consider when you're evaluating something like this is that it is going to be on that bleeding edge. It is going to provide new protection that we previously didn't have access to.
Yeah, right. That's a super important piece. For instance, I think we all remember WannaCry when that came out years ago. An agent that we had built maybe, I think it was 2 to 3 years before that exploit, that attack even came out, actually detected it without any adjustments. And that's the reason why you see so many companies shifting to using artificial intelligence for detection, because they don't have to have, you know, a group of researchers writing line by line rules to detect everything or signatures. It's very important. So, but yeah, I'll stop there. Go ahead.
All right, great. Well, thank you. Alex, is Alex still on? Alex, you have anything to add, or are you good?
I am still on, and I do not have anything to add. I think Will covered the one thing that I was going to.
Okay, all right, fantastic. So obviously, if you want more information about SentinelOne and how this solution can help protect your organization, definitely reach out to the person that had invited you to this, and you know, we'll circle back and get Will, Alex, and Steve back on. So excellent. So if we don't have any more questions, we're going to jump right into the again, the raffle here. So we have two different e-cards that will be emailed over to the winners. First one, Patrick Leduc. So Patrick, are you still on? If you can either go off mute or just chat that you are still here, because you do
still here. Thanks, man. Appreciate it.
All right, excellent. So you'll be hearing from us. Congratulations. And our second winner is John Dottie. So thank you very much, John. I know looks like you're still online here.
Hey, congrats.
All right, excellent. Nice job. Thank you for the
I like the
question.
chat, John.
Yeah. Fantastic. So we're gonna wrap this up, get you back to your day. Obviously, you know, we all are multitasking these days. So appreciate your time. Steve, again, great job. Alex, Will, thank you so much for helping us with this. And for the folks that did join us, you will be receiving the recording, so you can pass that along to folks in your organization or rewatch it. I know I'm going to rewatch some of that because Steve, you did an excellent job. So really appreciate that.
Yeah, thanks for having me, everybody.
Yeah, it was
Thank you, Steve.
fantastic. And
Thank
nice
you,
job
everyone.
emceeing, Joe.
What's that?
Nice job with your emceeing today.
Yeah,
Yes,
thanks very
good
much.
job, Joe.
I do my best. So. All right, enjoy, everyone.
Take
Thanks,
care.
Thanks,
everybody.
everyone.
Have a great day.
All right,
Thank you.
thank you.